Hello, STEM and technical education. My name is Matt Kirchner. I am president of ATS Lab Midwest and Mission Learning Systems. If you are not familiar with us, we are among the largest, if not the largest, distributor of technical education learning systems in the United States of America. I'm here to talk with you today about artificial intelligence, particularly in K-12 education and more specifically in middle school and high school. We all know that AI is playing a huge role these days in the world of education. If you are an educator, if you're a teacher, an instructor, a professor, you know that there are all kinds of ways that you can use generative artificial intelligence. You see many of them on the screen in front of you right now. We can use AI to write lesson plans. We can use AI to do assessments, all kinds of great applications for artificial intelligence. Your students, by the way, are also using AI, and they are using it as a virtual tutor. Maybe they're spending time creating AI generated images. One of my favorite things to do, actually, when I'm using artificial intelligence, maybe they're using it to help prompt some of their thinking or their writing or their coursework. All kinds of applications for our students to use generative artificial intelligence. And that's when most of us think about AI, we're thinking about generative AI. We are thinking about platforms like ChatGPT or Meta AI or Claude or Perplexity. I use all of those all the time. And yes, they are all artificial intelligence. But artificial intelligence in education can be so much more than just the generative AI, the generative pre trained transformers that we're using. That's what we're going to talk about today. Because the truth of the matter is, when it comes to how we use AI inside the classroom and inside our labs, there are some really, really cool ways to do it. Rather than just thinking about ChatGPT, what if we talk about something that's super relatable to our students? What if we talk about a platform like Spotify? Have you ever noticed that Spotify or maybe another application that you use all the time on your phone can predict the future in real time? Maybe it's Apple Music, maybe it's another music streaming service. How does it always know exactly what song you want to hear at exactly that point in time? Well, the truth is that Spotify, for example, knows everything about you. It knows your date of birth, it knows where you live, it knows your payment history, it knows what kind of music you listen to, it knows what songs you skip, what songs you pause on, what songs you play over and over and over. It knows who you follow, it knows who follows you, and it knows what kind of music those people like. And using all of that information and artificial intelligence and machine learning, it is predicting exactly what song you want to hear at exactly the point in time you want to hear it. Why don't we teach AI using a platform like Spotify? You see, the truth of the matter is, Spotify exists in what I like to call the edge to cloud continuum. That means smart sensors and smart devices out on the edge. Did you know that your smartphone has 23 different smart devices and smart sensors that are monitoring everything you do all day long, sending that to a control system we call our smartphone, and then we send that through Wi-Fi routers and modems through an internet service provider up to the cloud, where Spotify can perfectly predict the next song you want to hear. Well, guess what? That is true in terms of using our smartphones. That is true in terms of that edge to cloud continuum using Spotify, but it is also true across every single sector of our economy, whether it's advanced manufacturing, whether it's energy, defense, hospitality, retail. It doesn't matter. Every single one of those areas is an area in our economy where that edge to cloud continuum is really, really important. And this is how we can teach our students artificial intelligence in a really, really creative way using a platform that we like to call Discover AI. And in this video, we're going to talk about what is Discover AI and how is it totally revolutionizing the way we're delivering learning in what we call applied artificial intelligence across the United States of America and beyond. Now, I spend a lot of time in education. I spend a lot of time visiting with educators, going in and out of elementary schools, middle schools, high schools, tech colleges, universities, and so on. There are a lot of folks that are teaching artificial intelligence and just teaching generative AI or programming or coding. And I walk into classrooms and a lot of students look exactly like this. They're not particularly engaged. In fact, I talked to a student in my network about a half a year ago who said that their artificial intelligence course was their least favorite course in all of their coursework. That is horrible. That student was sitting there and they were learning about programming and coding, and they said all they really did was watch videos about AI. They said it was totally boring. What a shame. Artificial intelligence should be the most interesting course that one of our students has. Let's look at what Discover AI can offer. Now, doesn't that seem like a more interesting way to teach artificial intelligence than sitting a student in front of a computer, either programming or watching videos about AI? What we're going to spend the rest of this video talking about is how we can put that kind of learning right into your classroom. So rather than having students that look like this, we have students imagine walking into a lab that looks like this. And not just a lab that looks like this, but one that is full of hands-on, interactive, haptic zone learning where students experience applied artificial intelligence firsthand. Here's how it works. Students begin with an introductory course to applied artificial intelligence, learning in an e-learning course that is about 12 to 16 hours long, all about applied artificial intelligence. Then they move on to 12 different AI experiences. They can do all of them, they can do some of them, each of them about a quarter long. Finally, they go to AI mastery, where they can go deep in a wide variety of different AI experiences, creating for themselves a competency portfolio that shows any educator, any potential employer exactly what their portfolio of AI understanding, aptitudes, skills, and abilities are. So let's start with this introductory course to artificial intelligence, where students are learning what is artificial intelligence. They're learning all about that edge to cloud continuum we talked about, how we take information from smart sensors and smart devices on the edge and send it up to the cloud. They're learning about applications of artificial intelligence that are going on all around them in their daily lives. And finally, and just as important as everything else, they're understanding about the great careers that might be available to them while they are going through this education process, and of course after they graduate, whether they're going direct to workforce or they're going on to continue their education after high school, learning about those great careers that are available to them at that point in time. So this introductory course, we follow a girl, a young lady in high school by the name of Zoe. She's going through a journey of learning about artificial intelligence. Zoe learns about the edge to cloud continuum through Spotify, and as she continues her journey, she learns all about applied artificial intelligence in all kinds of different markets, all the ones that we just talked about. She learns about applied artificial intelligence in the world of energy and smart manufacturing and advanced manufacturing and hospitality and retail and defense, and the list goes on and on and on. learning about applied artificial intelligence, what AI is, what machine learning is, what are the different definitions of machine learning and the different types of machine learning, doing that in an e-learning course. Now, this course starts out with about a 12-hour learning experience. And that's that first part. So they're taking that 12 hours to learn the basics of AI. And then they go through an introductory course, which takes 30 minutes and looks at every single experience that they could be experiencing in their Discover AI lab. So they're learning all about how they can experience applied artificial intelligence in 12 different areas. And that's where we get to this next step. Once they're through with that e-learning course, 12 to 16 hours of e-learning, depending upon the pace of the student, they're going in and they're learning about applied artificial intelligence and all of these different disciplines. Look at this list. I mean, can you imagine a high school student being able to choose from any of these 12 or maybe doing all 12 of these applications, everything from autonomous vehicles to programming and coding to smart energy to 3D design and fabrication. Some of these things, some of us might not even be familiar with, but they are great ways for us to teach our students about the applied artificial intelligence application and about applied artificial intelligence in and around them. Let's go a little bit deeper into these student experiences. Like we said, there are 12 of them. They are hands-on experiences. Students are interacting directly with the technology and understanding how AI lives in and around every one of those technologies. They were talking about the careers that are available to them in every one of those particular areas of our economy. These are self-paced, independent courses. This is the future of education, where a high-flying student that can get through the coursework faster is able to do that. Where a student who needs a little bit more time to go through their coursework is also able to do that. Self-paced and independent-led courses all designed to be about a quarter in length, half of a semester, about 45 hours per project, and we can adjust that based upon the individual school's time frame and school calendar. They earn badges upon completion, so they are getting credit for their work. They are earning valuable badges, and they are earning credentials as they go through those processes. And then when they get to AI mastery, they can choose one or every single one of these different experiences. They're earning industry recognized certifications. In many cases, they can take those certifications on to whatever happens after high school, getting credit, dual credit at community colleges, at universities as a result of their coursework in high school. And they graduate, and this is the future of education, with a competency portfolio that is different for every student. So yes, they're going to get a diploma upon graduation. They also have this collage, this collection of badges, certifications, and certificates that show the work that they did in high school, different for every single student in terms of what their individual interests are. So let's go deeper into what all these experiences are. Let's talk first about autonomous vehicles, the self-driving car STEM lab from Quanzer. If you haven't ridden in a self-driving vehicle, I actually have at Phoenix, Arizona. It is a crazy experience. But guess what? Autonomous vehicles are going to be everywhere. They already are. They're being introduced all over California, all over Arizona, coming soon to the state of New York. And we use these vehicles, we use this platform. Students are interacting directly with this technology to teach the edge to cloud continuum and autonomous vehicles. They are learning how we use LiDAR and 2D and 3D cameras and sensors on the edge, sending that information to an onboard microprocessor that is our control system, then going on to the fog, in this case, a classroom computer, and where we're doing real-time object detection. We are using classification machine learning. We are using reinforcement machine learning and supervised and unsupervised machine learning. Students are learning firsthand how every single AI-backed technology is able to do four things. They're all able to see on their own, they're able to think on their own, they're able to act on their own, and they're able to communicate with each other. And they are learning that through this experience with autonomous vehicles. How about biotechnology? Who hasn't heard about the great things that AI is doing in the field of medicine? We get students firsthand, upfront and close with this technology using the NeuroMaker Hand 2.0. They're learning about biosensors. They're learning about a brain-computer interface, literally something they put on their head that reads their brainwaves, and they are controlling systems using their brainwaves. I mean, think about learning in that environment. At the edge, we're talking about bio and smart sensors and that BCI, that brain-computer interface. When we go up to our control systems, we're talking about Raspberry Pi and microbit microprocessors that are basically gathering data on the edge, sending that to a classroom computer, and then using cloud-based machine learning and artificial intelligence models to analyze biosignals. How cool is that for a student who's interested in a possible future career in medicine where artificial intelligence is changing absolutely everything? Autonomous mobile robots. These are driverless fork trucks. This is the way that we are now moving material around manufacturing and distribution centers. In this case, we're using the Auto AMR. This is a driverless fork truck. The students are actually operating and programming this technology. So out on the edge, they're learning about LiDAR cameras and sensors. There is an onboard microprocessor on that particular unit, the Auto 100. They're communicating to a plant network or a regional data center. In this case, they're communicating to a network inside the classroom, inside the lab. And then at the cloud level, we're using AI to optimize material flow through a manufacturing environment, through a distribution facility. So these things will literally map their own, they'll create their own map of their environment, and they'll use artificial intelligence and machine learning to do things like avoid collisions, drive around people and other objects. If two of them are going to meet in the same aisle, one of them will redirect itself. Literally using artificial intelligence to optimize material flow through a manufacturing or distribution center. 45 hours of learning here for our students to learn about that application. Unmanned ground vehicles, right? Who isn't fascinated by watching a vehicle drive around another planet? We are literally using a Mars rover or a version of it, a model of it, for our students to learn how unmanned ground vehicles, whether they are on the planet Mars, whether they are going around an environment here on Earth, how those things work, how we take smart sensors out on the edge and we take information from those sensors, we send it to an onboard Arduino, which is a microprocessor. Then we're using technology like GPS and telemetry to allow that Mars rover to plan its own path, to do mapping, to avoid obstacles. We're tying this back to a computer where students are programming it. They can literally set that UGV out in the parking lot at the school and map it on cloud-based software, and that vehicle will drive exactly where the student mapped the vehicle to drive. We can do the same thing with unmanned aerial vehicles. Think about how drones are totally transforming everything from agriculture to safety and security to law enforcement to search and rescue and to delivery and so on. We teach our students about drones using the Mind's Eye UAV drone. This isn't just about flying a drone, that's fine, but this is about how do we assemble all the pieces and parts into a drone so that our students are able to understand every single one of those edge to cloud technologies, from LiDAR and computer vision systems out on the edge to an onboard microprocessor. There again, GPS and telemetry. And in this case, we can do AI backed object tracking, target identification, aerial mapping, using the edge to cloud continuum, using artificial intelligence, an entire quarter of learning that technology in a high school. Programming and coding. Here we are using the Mastery Coding platform, teaching students computer science foundation using the Python programming language. When we think about our edge to cloud continuum, this is focusing on what is happening in the cloud. What is the syntax? What are the variables and the data types? What algorithms are we using and how do we develop an algorithm? How do we do the magic on the cloud that enables artificial intelligence and machine learning? If that's not their thing, what about precision agriculture? In the same way that we're using those Mars rovers to do really cool operations, we are totally transforming agriculture. The way that we prepare the soil, the way that we seed, the way that we fertilize, the way that we irrigate, the way that we harvest is all now done and can be done using artificially intelligent technology. And so when we think about the Mind's Eye self-driving tractor, which is great for any precision agriculture program, we've got all the edge sensors that are measuring things like moisture and temperature and rainfall and so on and so forth, talking to an onboard microprocessor. Then we use real-time kinematic GPS to be able to track that particular tractor's driving throughout, in this case, a modified field. And so we can do this in the parking lot. We can do this out on the football field. We can teach students how to program that technology and then using cloud level AI to optimize the management of our crops, to map our fields and to map and understand our different resources that go into creating a really, really efficient agriculture environment. Industrial robotics using the FANUC cert card. So we can do all kinds of things with robotics, and certainly learning how to operate and program an industrial robot, really, really important. But think about all the other things that we can do with the FANUC cert card. We have all kinds of smart sensors on those cert cards that are measuring things like temperature and disturbances and force and moisture and humidity, sending that information to the robot controller and in turn to a data collector or a plant network or a regional data center and then up to the cloud, where we use technology like MT-Link I and ZDT to be able to predict the future, where robots can literally predict their own future failure and order their own replacement parts before the failure ever happens, and our students can learn that technology. Same thing goes for smart manufacturing. Our partner Amatrol has incredible mechatronics smart factory technology where students can learn all about smart manufacturing, how we're gathering and acquiring data out on the edge and sending it up to the cloud to analyze it. And so we are teaching things like all kinds of really cool sensors, proximity sensors, photo eyes, light sensors, barcode readers, smart RFID, smart ultrasonic sensors. When we talk about a smart sensor, it means that it can communicate with other sensors and that it has embedded intelligence. It can make its own decisions. Then we just send what we need to up to a programmable logic controller. That's the computer of manufacturing. Then to a plant network or a regional data center, and then up to the cloud where they are learning how software like iGear and Squeaks, so maintenance and health predictive software and ERP and MRP software are used, leveraging artificial intelligence in the edge to cloud continuum in advanced manufacturing. Same thing goes for smart energy, whether we're talking about solar PVs or we're talking about wind energy or biofuels or hydro. We think about how the edge to cloud continuum manifests itself. In this particular case, using the Lex Solar New Energy experiment kits, we focus on the edge and we focus on the cloud. Out on the edge, we've got photovoltaics and biofuels and wind and data acquisition and all the sensors we can use to measure what's going on there, sending that information up to the cloud. We're teaching students how we acquire data, how we analyze that data, and how we use that data to improve performance. Really, really important fundamental competencies in advanced artificial intelligence. 3D modeling and game development. What student hasn't dreamt about being a video game developer? We're using that platform, Mastery Coding's Game Development Foundations and Game Development One, to equip our students not just to understand how to make their own video game, which is pretty cool to begin with, but also understanding how that manifests itself in the edge to cloud continuum. Again, mainly focusing on the cloud, where C# and Blender software are utilized and leveraged, and students are learning that technology, how we generate images, how we can understand enemy behavior, for example, when we are using artificial intelligence and building a video game or using AI in decision making in a video game as well. Really, really cool technology, great opportunities for our students in a controlled environment to learn game development and build some really important cloud-based programming and coding skills along the way. 3D design and fabrication. This is where we are teaching students how to use a scanner, a 3D scanner, a scanner that can literally scan something as large as a rail car and build a perfect 3D model of that rail car with a tolerance of about 75 micrometers. So we are really, really getting into almost nano-based measurement when we're using 3D design and fabrication and when we're using the Creaform scanning technology. We also use 3D printer from B9 Creations, doing really amazing work in terms of teaching students the differences in materials and how to create 3D prints using a variety of materials and doing it to a tolerance that would blow you away, within 50 microns, believe it or not. And so all kinds of opportunities, all kinds of really, really cool opportunities for our students to learn 3D design and fabrication using the edge to cloud continuum. So we're doing high-res scanning, we're understanding materials, we have a scanner, we have our printer out on the edge. Those are all full of sensors that are gathering data in real time, sending that information to a computer or to the control system on the printer. And when we get to the fog, that is the network or the data center where we are collecting that data. And then up at the cloud using technology like VX Integrity, Scan to CAD, CAM, material development, using artificial intelligence, understanding the edge to cloud continuum in this application. So many cool ways for us to deliver this learning. Once again, we have an introductory course where students are going through an e-learning course, introducing them to artificial intelligence and machine learning. Then they get to choose from as many as 12 AI experiences. Maybe they want to do all 12. Maybe they're interested in just a few. And then for those students then that want to go even deeper and earn certifications and earn advanced credit, earn dual credit, we can go into that level of AI mastery where students are learning in a really controlled environment, self-paced, independent learning. So that is Discover AI. It is turnkey and scalable. You don't have to do all of the experiences. You can just do a couple of them. It's all hands-on. It's all interactive learning, the way students love to learn, industry relevant, tied to careers, self-paced and modular. Your great students, and your fast students, your students that are a little bit ahead, those students can move ahead. They can go faster. If a student needs a little bit more time on a specific subject matter area, they can do that as well. All tied to credentials and certifications that have value in the world of work and in advanced education. And best of all, if you're a teacher, if you're an instructor, you do not need to be an expert on artificial intelligence. We will train you well enough to be able to understand these applications, plenty of resources for you to bring this technology into your classroom. Let's get away from technology education and AI education looking like this, and let's get into the age of Discover AI, where we have highly interactive, really exciting opportunities for our students to study AI, to learn AI, to understand the careers associated with AI, and then to take their futures wherever they may. Thank you so much for being with me on this presentation of Discover AI. If you're interested, our friends at Mission Learning Systems, Lab Midwest, and ATS Midwest would love to get together with you to share more.